Hello, today we'll talk about exponentiation and logarithms. So first of all, let's start with exponentiation. It's the operator with two asterisks. Let's start with the integers. If both of them are integers, the result will be int. If at least one of them is a float, the result will be a float. Let's also go to the floats. Again, if at least one of the operands is a float, the result will be float. So we can say five raised to the second. That is going to give us 25. There it is. But we can also use another method, which is called pow, on power. We give the base and the exponent. Here's the description. It returns a result of base raised to the power of exp. This is the same as the asterisks, but the result will always be float. So if we run this, we get the same result. As you can see, now we have the point 0, which means that this is a float. Let's create a variable. Just like with the other operators, we can combine it with assignment. So if we try to print number after this command, it will change to 25. Now the same rules apply as we know them in mathematics. If we try to raise to the 0, we get 1. Let's try to raise to a negative number. Let's say that we have 4 raised to the minus 1. Now both of them are integers, so the result will be 0. If we change at least one of them into a float, we get 0.25. That's because 4 raised to the minus 1 is basically 1 over 4. We can also use negative numbers for the base. Hold on. And it works as expected. Now, if the base is 0, let's say 0 raised to the third, the result will be 0. 0 raised to any number will always be 0. But what if we raise it to the 0? Now the result is 1. If we try a negative number, we get the smallest int. If we check the documentation, it's this number. However, if we change this to a float, we get infinity. That's because this is basically 1 divided by 0. If we use the pow method, we still get the same results. Since the exponent can be a float, we can also use this to get roots. Let's say 4 raised to 1 divided by 2. And we make sure this is a float, so the result will be a float number. Otherwise, this would be 0. And we get 2. This is the same as getting the square root of 4. Let's say we want to get the 8th root. We just use 1 over 8. And this is the 8th root of 4. Specifically for the square root, we also have a method, sqrt. And we just give the number. Here's the description of the method. It takes a float and it returns a float. But if the input is a negative number, we get none, not a number. If for some reason you want your game to handle imaginary numbers, you will have to use C#. So as you can see, if we pick a negative number, we're getting not a number. In C#, if we use the complex class, this would be 5 times I, where I is the imaginary unit. Okay, now let's move on to the E. This is the natural exponential function. It uses the mathematical constant E, and it raises it to the x. So if we just want to get the number E, we can set the input to 1. And this is an approximation of E. Okay, now let's move on to the logarithms. This method returns the natural logarithm of x. Basically, this is the inverse of exp. Exp raises E to the input, while log finds the power that E has to be raised to get the input. Okay, this is not the same as the log function on most calculators. Okay, we'll talk about this later. So the logarithm of E will give us 1. That basically means to what power should we raise E, so that the result will be E raised to the first. And the answer should be 1. If we have E cubed, for example, then we need to find the number x, so that when we raise E to the x, we get E cubed. And that is the number 3. Since it's the inverse, flipping this will give the same result. Now let's talk about changing the base of the logarithm. If we want to use a log base 10, we have to use the log function and then divide by the natural logarithm of 10. So let's say that we want to get the logarithm of 8 base 2. In other words, 2 raised to the x should be equal to 8. So x has to be 3. In order to do that, we have to divide by logarithm of 2. So if we run this, we get 3. We could also make a function for this. Let's name it log2. And it just returns logarithm of x divided by logarithm of 2. Now let's try other powers of 2. For example, 32. This should give us 5. Sorry, I'm dumb. This would give us 5. And we can use that for any base we want. Let's say for base 3. Let's change this to a 3. Change the name of the method. And give it 27. 3 raised to the third gives us 27. What happens if we try to get the logarithm of 0? We get negative infinity. That's because log goes to negative infinity as we approach 0. It says it over here. The logarithm of 0 returns minus infinity. Negative values return minus none. So if we try a negative number, let's say minus 1, we get not a number. Now you could make a class for complex numbers to calculate negative logarithms, but that's outside of our scope. So let's move on to the last method for today. And that is the nearest power of 2. It returns the smallest integer power of 2 that is greater than or equal to value. Okay, this looks a bit complicated, but it's pretty simple. Let's say we give the number 3, and we want to take a power of 2 that is as close as possible, but it has to be greater than the input. And that is the number 4. If our input is already a power of 2, it just returns the same number. Now for 0 and minus 1, we can see that we get 0. And it's also warning us here, due to its implementation, this method returns 0 rather than 1 for values less than or equal to 0. With an exception for value being the smallest negative 64-bit integer, which is this one, in which case the value is returned unchanged. I'm just going to add that this is not the only case where we get this value, but we'll talk about that later. For now, let's focus on the normal use of this function. Let's say we have the number 12. Yeah, we need the string function. And we want to get a power of 2 that is as close as possible to 12, but it has to be greater. Those are powers of 2, 2 raised to the third, 2 raised to the fourth. So the result is going to be 16. Okay, so far so good. If the number is already a power of 2, let's say 32, the result will have to be the same. Now let's try 0, and the result is 0. That is because of the implementation of the method. Now, I don't want to get into too much detail, but it's something like this. We have our input, we subtract 1, and then we use OR and shift operators in order to turn the number into something like this. Its binary form is going to be a bunch of zeros followed by all ones. Now we'll see later where this point is going to be between the zeros and the ones. And then we increase the number by 1. Keep in mind this is a number that's going to be all ones. So in binary form, the result will be 0b, a bunch of zeros, 1, followed by zeros. And this is a power of 2. So let's see with an actual example. Let's say that x is equal to 10. Then we have to subtract 1, so it becomes 9. And then, with the OR and the shift operators, this is the binary representation of 9. And after we use this part of the method, the result will change into 0b, zeros, and 4 ones. To put it simply, we read our number from left to right, and as soon as we find the first one, we change every digit after it into 1. So we change those 3 digits into 1. And this is the number 15. Now we increase it by 1, and it becomes 16. In binary form, this would be 1 followed by 4 zeros. Indeed, the smallest power of 2, which is greater than 10, is 16. Now you may be wondering about this part. That is in case we have already a power of 2, let's say 8. If we were to only run this part of the code, the number would be 1 followed by 3 zeros. The OR and the shift operators would change this into 4 ones, which is 15. And then we increase it by 1, and it becomes 16, which is wrong. We wanted this to be 8. But if we subtract 1 from the beginning, we get 7. So the number is going to be 111. And of course we have the zeros over here. I didn't add them before. So this is not going to change anything, because the number is already in this form. And then we increase it by 1, and it becomes 8. Now let's try another example, where the number is 0. Then we get minus 1, and because of the 2's complement, every negative number starts with 1. Specifically, minus 1 would be all ones. So this thing over here is going to read the first one, which is right at the beginning, and change everything into 1. So the result is the same as before. Then we increase this by 1, and due to overflow, the number becomes 0. Okay, so someone might think that this method returns powers of 2 and 0. Wrong. There is another. We also have one more case where the method returns the smallest integer. In order to achieve that, the return value has to be 1 followed by all zeros. Let's try to take the smallest integer, as it suggests over here. And let's see the result. We are getting the same number. And that's because basically it subtracts 1. And due to overflow, this number becomes the greatest integer. So it becomes this number. In binary form, this is written as 0b, 0, and then all ones. And if we increase this by 1, we get 1 followed by zeros, which is the same as before. Now there are a few more exceptions where we can get the same value. For example, if we pass the greatest integer as an argument, we still get the same result. So in this case, we could say that if the number is negative, return 1, which is the smallest power of 2 we can get. However, let's say for some reason we want negative powers of 2, like minus 2, minus 4, minus 8, and so on. In this case, we could say, take the absolute value of the input. We haven't really talked about this function, but it takes the absolute value of the input. and the input can be integer, floats, and vectors. We'll see this in a future video. For now, this just turns the number into a positive. So we get 3. And then we just place a minus. If we run this, we get minus 4. Now remember, the method returns the smallest integer power of 2 that is greater than or equal to value. When it comes to positive numbers, 4 is greater than 3. But because they are negative, minus 4 is less than minus 3. If we want to take the power of 2 that is greater than the input, we take this number and we shift it by 1. And now it's minus 2. Basically, we had 4, shift once, and because we're shifting to the left, we get the previous power of 2. Okay, that was it about exponentiation. In the next video, we'll see a few examples where we use these functions. Till next time.